Introduction: the tiny titans powering our world. Our world thrives on computation. Every second, billions of calculations are performed, enabling everything from simple text messages to complex scientific simulations. This computational power is the backbone of modern society, driving innovation and efficiency across all sectors. Smartphones, laptops, cars, even refrigerators depend on the silent hum of semiconductors. These tiny components are the unsung heroes of our digital age, seamlessly integrating into our daily lives and making the impossible possible. These tiny chips, measured in nanometers, are the brains behind our digital lives. Despite their minuscule size, they pack immense power, enabling devices to perform complex tasks with incredible speed and efficiency. As we demand more from our devices, the need for smaller, more powerful chips intensifies. Scientists and engineers are constantly pushing the boundaries of what is possible, striving to create chips that are not only smaller but also more energy efficient and capable of handling greater workloads. Enter the realm of 10 nanometers and below, a scale so minute that it rivals the width of a few strands of DNA. At this scale, the physical properties of materials change, presenting both challenges and opportunities for innovation. These advanced chips are not just about faster phones or sharper graphics. They are integral to the functioning of critical infrastructure, ensuring the reliability and efficiency of telecommunications, healthcare, and other essential services. They underpin critical infrastructure, from telecommunications and healthcare to defense and aerospace. In these fields, the performance and reliability of chips can be a matter of national security, influencing the balance of power on a global scale. The ability to design, manufacture, and deploy these technological marvels has become a strategic imperative. Countries and companies invest heavily in research and development to stay ahead in the race for technological supremacy. Understanding this complex ecosystem is crucial to navigating the geopolitical and economic forces shaping the future of technology. As we move forward, the role of these tiny titans will only grow, driving progress and innovation in ways we can only begin to imagine. The linchpin: advanced lithography and its gatekeepers. At the heart of semiconductor manufacturing lies a critical piece of equipment: the extreme ultraviolet lithography machine. This engineering marvel etches microscopic patterns onto silicon wafers, creating the transistors that form the building blocks of modern chips. The complexity and precision required to build these machines are staggering, with only a handful of companies worldwide possessing the necessary expertise. The Netherlands-based ASML holds a virtual monopoly on the production of EUV lithography machines. This dominant position gives ASML, and by extension the Netherlands, outsized influence over the global semiconductor industry. Access to these machines is paramount for any nation or corporation aspiring to compete in the production of advanced chips. A house of cards: centralization and its discontents. The semiconductor industry exemplifies the double-edged sword of globalization. The COVID-19 pandemic laid bare the fragility of global supply chains, leading to shortages and delays across industries. The semiconductor industry, with its intricate web of interconnected suppliers and geographically concentrated production, was particularly hard hit. The automotive industry experienced significant production slowdowns due to chip shortages. This highlighted the risks associated with over-reliance on single sources for critical components. The current geopolitical climate further amplifies these risks, underlining the need for a more resilient and diversified approach to semiconductor manufacturing. When silicon meets geopolitics, a fraying global order. The semiconductor industry has become a focal point in the escalating rivalry between the United States and China. The U.S. has imposed restrictions on Chinese companies' access to advanced chips and chip-making equipment. China is investing heavily in developing its domestic semiconductor industry. This technological arms race impacts global trade, investment flows, and the balance of power on the world stage. The semiconductor industry, once a symbol of global collaboration, has become increasingly politicized. The ability to navigate this complex landscape and forge strategic alliances will be critical for national competitiveness and security. Charting a new course: resilience and regionalization. The fragility of the global semiconductor supply chain has exposed the limitations of the hyper-globalized model. The need for greater resilience and diversification is evident, prompting a reassessment of global supply chains and a shift towards regionalization. Governments and corporations are increasingly looking to diversify their sources of critical components. This involves fostering domestic industries, forging strategic partnerships with like-minded nations, and promoting regional production networks. The goal is to create a more robust and shock-resistant system. This shift towards regionalization is driven not only by concerns about resilience, but also by geopolitical considerations. The future of the semiconductor industry will be shaped by this interplay of economic and geopolitical forces. Building blocks of the future: diversification and innovation. Building a more resilient and decentralized tech ecosystem requires more than just shifting production locations. Diversification of suppliers, technologies, and manufacturing processes is crucial to mitigate risks. Investing in next-generation technologies such as quantum computing and advanced materials is essential. Collaboration between industry, academia, and governments is paramount to accelerate research and development. Emerging economies represent a significant opportunity for growth and diversification. By fostering local innovation ecosystems, these countries can become key players in the global semiconductor industry. The talent equation: cultivating a global workforce. The semiconductor industry thrives on human ingenuity. However, the industry faces a growing talent shortage. Addressing this challenge requires a multi-pronged approach. Educational institutions need to adapt their curricula to meet the evolving needs of the industry. Governments should implement policies that attract and retain top talent. Companies need to invest in workforce development programs. The talent pipeline needs to be broadened to include individuals from underrepresented backgrounds. Investing in education, training, and mentorship programs for women, minorities, and other underrepresented groups is essential. Rethinking globalization: from efficiency to security. The semiconductor industry's challenges highlight the need to rethink the prevailing model of globalization. The COVID-19 pandemic and escalating geopolitical rivalries have exposed the vulnerabilities of this approach. Security of supply, national competitiveness, and geopolitical considerations are now taking center stage. Governments are increasingly intervening in the market to protect domestic industries. Companies are reassessing their supply chains and diversifying their sources of components. The focus is shifting from a purely efficiency-driven model to one that balances economic considerations with strategic objectives. The semiconductor industry will be at the forefront of this transformation. The sustainability imperative: greening the chip supply chain. The semiconductor industry's pursuit of miniaturization and performance comes at an environmental cost. Manufacturing these tiny titans requires enormous amounts of energy and water. Addressing this challenge requires a comprehensive approach that encompasses all aspects of the chip supply chain. From designing energy-efficient chips to promoting responsible sourcing of raw materials, sustainability needs to be integrated into every stage. This transition to a more sustainable semiconductor industry presents both challenges and opportunities. Embracing sustainability is not just an environmental imperative, but also a business opportunity. Collaboration and competition. Navigating a multipolar world. The semiconductor industry stands at a crossroads. Geopolitical tensions, supply chain vulnerabilities, and the imperative for sustainability are reshaping the global technology landscape. Navigating this complex environment requires a delicate balancing act. International cooperation is crucial to address shared challenges. Sharing best practices and coordinating research and development efforts can accelerate progress. However, the ability to compete, both economically and technologically, remains paramount. The future of the semiconductor industry will be shaped by how effectively we navigate this complex interplay. Conclusion: a future etched in silicon. The global chip crisis has laid bare the critical role semiconductors play in our interconnected world. From powering our smartphones to underpinning critical infrastructure, these tiny titans are the lifeblood of the digital age. The future of the semiconductor industry hinges on addressing these challenges. Building a more resilient and decentralized tech ecosystem requires diversification of suppliers and a renewed focus on innovation. Investing in education, cultivating a global workforce, and embracing sustainability are crucial. Navigating the complexities of a multipolar world demands a delicate balancing act. The future is yet to be written, but one thing is certain: it will be etched in silicon.